So later I can share it. Yeah. So today we discuss about flow controls in Java, flow controls in Java. Maybe like you may have an idea of basic flow controls in C or C++ or in Java or maybe some other programming languages. The flow controls are it's a basic concept, fundamental concepts which we see in each and every programming language, right? So what is flow control? Basically, if you look at the statement that flow control, how can we define this flow control? How can we define this flow control? What is a flow? Basically, like flow in the sense it can be like something is moving, right? Something is moving. That can be a liquid or something else, right? That can be that can be a water. So in our programming language, we talk the flow in terms of statements execution. In terms of executing the statements, the statements are Java statements, right? As we write Java programs, we say the flow is uh, Java statements execution flow. The Java statements execution flow. So if you look at my basic class class sample, if you look at, we'll be writing default main method, and inside we write number of statements depends on the requirement. So I can use multiple print statements like this. I can write multiple statements. So here one more statement or some other statements. Like this, I can write 10 statements. I can write 100 statements. I can write 1000 statements also in my method. It's all depends on my business requirement, nothing but business logic, programming logic. Basically, it depends on the programming logic. Number of lines depends on programming logic. I'll say business logic. I'll say business depends on the business requirements. Fine. So as I have these many statements in my main method, as I have these many main methods in my these many statements in my main method. So how JVM starts its execution? How JVM starts its execution? If you look at it, comes from main method. Of course, JVM starts its execution from main method. It executes this particular statement, and then it comes to this particular statement, then this statement, this statement, this statement, and so on, right? So as JVM blindly executes statement to statement, so there is no mechanism that JVM automatically controls your flow, execution flow. What JVM does is JVM executes the statements line by line. JVM executes the statements line by line. So it is the programmer's responsibility to change that flow as per the programming requirements, as per the business requirements. So let me repeat it. JVM blindly executes the statements line by line, line by line. If we want to change, we want to change the flow, the execution flow, it is programmer responsibility to control that flow by adding a special statements, by adding a special statement. That is what controlling the execution flow, nothing but a flow control in our programming logic. So that programming logic, the developer has to uh, uh, handle as per his requirements, as per his requirements. Say what is that requirement? Say for example, say let me take an example. So for example, I'm having uh, a set of numbers. I'm having set of numbers. So in that set of numbers, in that set of numbers, I wanted to separate those numbers. I wanted to separate those numbers like this. I'm having a set of numbers. I'm having now these are my input numbers. Now the requirement is that okay, identify or print separately even numbers and odd numbers, of course, as well as prime numbers, of course, prime numbers. Then what is the logic? Like if you look at this, so first we need to verify the number is even, odd, or prime. Then depends on this check, we proceed further, meaning everybody is uh, following, right? Hope you can see my screen and
Yeah,
you can hear my voice also. Hello.
yeah,
Yeah. Okay. So this is what my input said. Now my logic is depending on the check. What is the check? Whether the given number is even number or odd number or prime number. So depends on that I wanted to do something. What is that? So if it is even number, I'll say the number 1 or 2, the given number, basically even. So if the number is odd, I will do something else, not the same thing. If the number is odd number, then I will say okay, that number is odd number. So the printing statement is different, depends on my input number. So what is that? Just check something like if number is number is even. If the number is even, then I wanted to do something here. I wanted to do something here. if if the number is odd, I will do something here. So that something might be like simple printing statement or something else, whatever the logic depends on the requirements. The requirement is just to print. We will be having a printing statement saying that okay, the given number is odd number. In the above if blah, we will say the given number is even number. If number is prime, then we will say it is a prime number. So we'll be writing some piece of code here. So now what JVM does, JVM starts its execution here. Okay, it executes this piece of line. So what this piece of line is doing, it is verifying whether the number is even or odd. It is verifying the given number is even or odd. So if it is even, for suppose it is even, then only it comes into this particular block. Then only it comes to this particular block. And here whatever how many statements we have, all the statements will get executed. It can be one statement, it can be two statements, it can be three statements, or it can have 100 statements also. 100 statements also. But basic point is, if the uh, condition is true, meaning the number is even. If the given number is even, say 2 or 4 for 6, 8, for these cases, that is like it says that yes, the number is even. So whenever it says yes in programming terminology, we call it as a true. For S case, we say it is a true. For no case, we say it is a false. True or false. We treat it as true and false. So if the condition, like if condition is true, then do execute all these particular statements. To execute all these particular statements. So if the condition is not satisfied, meaning what? If the condition is false, the condition is no, number is even, no, nothing but false. If the number is not even, then I don't have to execute all these lines of code. How many lines of code I'm having? Could be a 10 lines or 100 lines. All those lines I don't have to execute. Now directly from this line to this line I wanted to move. I wanted to skip I wanted to skip a few lines of code. I wanted to skip a few lines of code. That is what my programming logic is doing. My programming is logic is saying to JVM, if this particular piece of condition is true, then only you execute this. Otherwise, don't execute these statements. Skip these statements. So somehow we are controlling the execution flow. Somehow we are controlling with our programming logic the execution flow. The execution flow. If number is even, do all these things. If number is odd, then do all this. If number is prime, then do all this. Somehow we are changing the normal flow of execution statement by statement. If there are no conditions, assume that this is not there, this condition is not there, then obviously JVM executes this line, all the cases. I mean, how many times you execute this program, every time it executes, JVM executes line by line only. So whenever it is executing, now we are introducing a programming logic where we can skip a few lines of code depends on a particular condition. Nothing but we are altering the flow. The normal flow we are altering. That is what controlling, flow controlling. We are talking about that flow controls. Now we are talking about that flow controls. So how many flow controls we have in our programming language Java? So if you look at flow controls, the basic flow controls, like we see something like if, we have if and else, and we'll be having if else, if else, if else ladder. I mean multiple if else if, again if else, if else, if else, if else, it's a ladder, or simple if else, or simple if condition. We'll be having flow control if, then we'll be having switch condition. I may have 10 conditions. Out of that I wanted to switch to uh, only one. It is something like our electricity board, something like, if you look at in our switchboard we may have 10 switch, but depends on my requirement. If I wanted to switch on my fan, I'll switch on only that particular switch basically. Then automatically my fan execution will execute. I mean my fan will start rotating. That is what the code execution. And operating is what, by pressing the switch related to fan, we'll be able to do that. Here also the same scenario. We'll be defining how many things we have in our programming requirement. Nothing but so I'm having a fan, rotating a fan, and I wanted to have a tube light. I wanted to switch on tube light. I wanted to operate my TV. I wanted to open my laptop. So these are like four conditions I have. So but at a time I may do one or two, right? At a time I wanted to switch on my fan, or at a time I can do switch on my fan as well as switch on my TV. Both the things I wanted to execute. So your switch statement exactly executes as your switch code. So anyhow, we look into that switch block more when we talk about that switch. Right, we will be having switch. So if and switch both are like relative. I mean both are related. We talk about that. Now after that, we have iterative statements. We have iterative statements which controls your flow. So iterative statements, so whenever we have some piece of code, which to be executed repetitively, which needs to be executed repetitively. So at that time, uh, to to control that flow, how many times it has to execute, how many times it has to execute repetitively, and what basis it has to fail and it has to come out of that loop. Basically, iterative statements, also known as looping statements, also known as looping statements, no programming laws. So it will loop through a piece of code. That piece of code can be again a 10 lines of code, 100 lines of code. Till the condition fails, it executes those 10 statements or 100 statements. So that those are like looping statements or iterative statements. We have different, again different kind of iterative statements. We have while, do while, and we have for, basic for loop, and we will be having for each loop. We have while, do while, uh, for for each loop. And yeah, we have one more flow control statement. We'll be having break and continue. Basically these are some special keywords, yeah, which takes its role to control your flow. These two small things also somehow controls your execution flow. Right, if else later, switch, while, do while, for, and for each loop, we'll be using break and continue. We'll be using break and continue. So for if else, we have some alternative also. That is what selective thing. Yeah, these are if your switch. These are selective statements. I can say selective statements. These are selective statements, and these are iterative statements. So here in the selective statements, we have, yeah, we'll be having something like operator called ternary operator. Yes, that also we can treat it as a selective statement. So instead of writing if condition like in single line, we can make it happen. That is what using ternary operator. So now, yeah. So if we, yeah, we'll look into now basic if condition, if else condition basically. Yeah. So far you are clear. Hello. Uh, Hello, Daneshwar. Hello.
చెప్పండి సార్ మ్యూట్లో ఉన్నా.
It's fine
హలో
actually. Yeah, fine sir. Actually, I don't see Satish. I think Satish is dropped or might be having problem. Okay, fine. Session is recording. We can say share it. Uh, Fine. Looping statements. Now, yeah, we'll look into if else ladder for today. Let me write a new program. I'm writing a very basic program. seen this sometime back, but still, yeah. I have a number index equal to 10, index equal to 10. Now I wanted to write a logic to check this number is even or odd. This was my logic. Now I wanted to write a logic to verify this number is a even number or odd number. So what is the logic to find out the given number is even or odd? We just like if the given number is divided by 2 and the remainder is 0, then we can say it is even number, otherwise it is odd number. So how can I get my remainder value? I'll say a remainder. How can I get my remainder value? So the number modulus operator 2, the number modulus operator 2 gives me a remainder value. So modulus is a special operator where I can get the remainder. So if I say division, I will get coefficient value, but that I am not interested. I am interested about my remainder. So if my remainder is 0, when my number is divided by 2, then I can say it is a even number. So what I'll say, if remainder. So to compare two values, we will be using a special operator called double equals to. Double equals to operator verifies the values. What is the remainder value whenever x mod 2 happens? That value is equivalent to 0 or not. That is what it verifies. Remainder is equivalent to 0 or not. That it verifies. So if you look at here, if remainder is 0, then I will say the given number is even number. I will say even number. If remainder remainder not equals to 0, if remainder not equals to 0, I will print odd number. It is odd number. I print it is a odd number. Okay, let me save my file. I have saved my file. Let me go to command prompt, go to D drive, core Java, and bash. Yeah. I'm compiling my if else test of Java. It is absolutely compiled with no issues. I can execute my program. Now if you look at, it is printing even number, but it is not printing odd number. Meaning it is skipping this statement execution. It is skipping this statement execution. Nothing but what? So somehow JVM is controlled by our programming logic to alter the flow of execution. If there are no conditions, JVM blindly execute all the statements, meaning it prints even number, of course it prints odd number also. But if you look at the output, it is printing only even number but not odd number, meaning it executes only this line. It is not executed this particular line because of our programming logic where we have added a condition. So my input number is 10. My input number is a 10. So now I am keeping 11. If you look at again we compile the same program, we execute it. Now this time it is printing only odd number, meaning it is executed this SOP but not this SOP because again of this because of this condition. So this time 11 mod 2 is returning a reminder as 1. So reminder equal to 0. No, it is not happened. Then directly it comes to this particular condition. So if reminder not equal to 0, yeah, 1 not equal to 0, then I can yeah, enter into this and execute this. So it is printing as odd number. Just a second. Right. So the reminder equal to x mod 2 is giving 1 in this case. So it is printed odd number but not even number. Right. Now there is a small overhead here. That is what, if you look at here, we are talking about yeah, whether the number is even number or odd number. And if you take any number, so, and whenever we are talking about either even or odd, we have only two options. We should say okay, it is even number, or we should say it is odd number, either of one, not both, right? So here, if you are added these conditions here and here two times, what happens whenever JVM comes to this line, it verifies your reminder equal to 0, reminder equal to 0. In the first case whenever the x value is 10, this is true, and it prints this value, and still it comes to here, this also it verifies, and in this case it becomes false, so it won't execute this. But the condition is verified here and here in both the scenarios. In the other scenario, if you look at the condition, now x value is 11, 11 mod 2, which gives me 1, 1 double equals to 0, which is false. And here if you look at remainder not equal to 0, this is true. Now it comes inside this and executes. But here what I'm trying to say is, in both the scenarios, JVM has to evaluate this expression, this condition verification here as well as here. But if you look at our programming logic, yeah, it is a common sense that we know it executes either of this, not both, right? So in that case, why do I need to add a special condition again? So why can't I skip this check? Why can't I skip this check? So do I have any alternatives for that to verify, to skip that? Yes, we have. So whenever you have only two options, do this or this, then absolutely you can rewrite the logic by skipping this. So what I'll do, instead of writing the condition, I will simply say else. I'll simply say else. I'll simply say else. That's all. So now this time what happens? So if reminder equal to 0, if this condition is true, it executes and it won't come here, and it doesn't need to perform any additional checks. It doesn't need to perform any additional checks. For suppose it is false, this condition is false, then also it will not perform any more condition checks. Blindly it comes to here and it executes this as it is else. Otherwise, if this condition is not met, then come to here and execute it. That's what it means. If else. So if else like has importance. If else has very importance. Of course, if you can understand the flow controls completely, you can happily write your programming in real-time project. The software engine is what we do, not really uh, great than your if else conditions. So what is the business logic? What should happen if this condition met? What should not happen when this condition is not met? So based on that we write like flow controls are very important. That definitely you have to concentrate. Right. Now this is a simple if else. This is a simple if else. Now I can say what is the case. I wanted to verify the given number is a even number or odd number or or a prime number or a prime number. Now what is this case? Like I have three cases now, not two. If you are having only two cases, then you can go with the if else statement blindly. So what is the case if I have three scenarios? Then definitely I have to write one more check. I have to write one more check. So what I'll do? So here I'll say if yeah, I'm reverting the code back. Let me write one more program. That will be better. Even odd or prime number. Yeah. So if, if so here I need to do some more things that if it is not a even number or if it is not a odd number, then it comes to the next levels to verify the number is prime or not. Prime or not. Yeah, in general, what is the prime number? The prime number is uh, divided dividable or divided uh, by only the same number or the number 1. Other than that, it cannot be dividable by any other number, right? That is what a prime number. Now if you look at, say, if I say 4, yeah, 4 can be divided by 1, 4 can be divided by 2, 4 can be divided by 4. So now the count, if you look at, it is 3. Count is 3. So I cannot say it is a prime number. Let me take the number 3. Yeah, it can be divided by 1, it cannot be divided by 2, and it can be divided by 3. Of course, the number, like the number which is greater than the given number, we don't have to verify. That is what, whether 4 is divisible your 3 or not, that we don't have to check because it's definitely not. So 1 and 3, so now count equal to 2. Now I can say it is a prime number. So basically the logic is, if the count is 2, then I can say the given number is prime number. If the count is greater than 2, then I cannot say it is a prime number. Now, so my formula here is, I wanted to find out this count. So for that I'll take a counter variable. Okay, count. Initially I'll make it as a 0. Now I wanted to uh, increase my this one. Okay, think, yeah. As of now, I don't worry about this logic, but I'm going to write a small logic with the for loop. Don't worry about this, just for as part of finding prime number. uh, Whether it is a prime number or not, I can explain you during the for programming. So inside this I'm verifying my if. So basically what I'm trying to do is to implementing this logic to find out whether it is a prime number or not. But actual our logic, our discussion is if it is like more than two cases. So now in this case I wanted to verify the given number is a even number or not, or odd number or prime number. So I can say here, if remainder equal to 0, I will say it is a even number, and else if remainder is not equal to 0, then I'll say it is odd number. So assume that it is not even number or it is not odd number, then I wanted to do something else, then I can say if else. If else, like this we will be keeping, uh, don't confuse. So I'm having one check, if condition, and otherwise else, then I'm checking whether the number is odd number or not, otherwise do it. Okay, I'm just slightly changing my logic. First I'm keeping this, then I'm keeping this. I mean i mean like, the definitely the even number cannot be a prime number. So if it is even number, it will not come to here. So I am putting this all together, one if else. reminder equal to 0 0 remainder. Yeah. Now I'm taking 11. I'm taking 11 and I'm just recompiling the program. I'm executing. It is printing odd number. So as my number is 11, it is saying that it is odd number. Now let me say 10. I'm recompiling. But I'm printing. Still it is printing odd number. Reminder. Not yet saved it. Let me recompile. I'm sorry. I think the program I have to compile is if else test 2 program. Not the other one. If else test 2.java. This I have to execute. Now you can see it is printing even number. It is printing so many. It is coming into this black, and out of this it executes any one of this. I think I made it complicated for me. But we try to understand that, like, whenever we have multiple cases, then we will go with the if else multiple if else statements. Let me show you very basic program. Say assume that the student marks, simple example, the marks I'm taking maybe 45 or something, and depends on his marks. I wanted to say his grade. So in that case, we'll say if marks less than or equal to 35, I wanted to do something. If marks are greater than or equal to 35, greater than 35, and basically, and yeah, we'll use this symbol to do the and representation, and marks less than or equal to 60, I'll say separate grade. If marks greater than or equal to 60, so I'll say less than greater than or equal to 60, I wanted to do something else. So yeah, this is what very basic example. Here you can understand that logic. Right. So here my logic is very simple. Now, if you look at a time, we will say either the student is having first grade, second grade, or third grade, or he is failed. Right. So at a time, we will not say he's passed, he's failed, and he is having grade 5 or grade 2, grade 3. We will say either he's failed or he is passed in the grade 1 or grade 2, grade 3, something like that. So any one of any one of all these three blocks will execute, but not all three. Any one of these blocks will execute, but not all three. But if you look at this piece of code, it verifies this condition first. If it is not satisfied, it comes here, verifies this condition also. If it is not satisfied, it comes here, and this it also verifies its condition. So whenever we are having multiple conditions, so to execute any one of the conditions, we can add our if else. We can add our if else. Again, here I can make else. So this is one if else, and again one more if else. Basically, it is a if else ladder. Now what happens? If the given marks is less than or equal to 35, so this piece of code will execute, and as this piece of code is executed, it will not execute all these pieces, all these conditions. If this is not satisfied, if the condition is false, then only it comes to here, and this condition will check. If this condition checks where it is true, then it executes this and it won't go for this. For suppose it is failed, directly it comes here and it executes this. That is what the importance of your if else ladder. Your if else ladder. So let me say uh, failed. Okay, simple as doing. So this is a past in second grade. Answer past in first grade. Right. Now if you look at my marks are 45. So as it is 45, first it like of course it is starting from here. It verifies. So less than 35 condition fail. It comes here. 35 to 60, yes, it is satisfied. Now whenever it is satisfied, from that point of time onwards, it won't proceed any other, it won't execute any other things. Right. So uh, first suppose let me give 15 here. Let me give 15 here. Now marks less than or equal to 35, yes, it is true. So it will print failed, and it will not come here and it will not come here. It will not execute any of this piece of code. It simply ignores, and directly whatever the code after that you have, that will execute. That will execute. That will execute. Now if you look at, compile this program, Java C, if else example. Okay, there is some problem. Main method is marks 15. If marks less than or equal to 35, else if marks what it is saying that. Oh, so in the case of else, we don't require the condition. That is what important observation you have to do. Whenever you are writing else will not have any condition. Remember that point. Else will not have any condition. Directly simply else. That's all. So if else, I'm executing now. So failed, and after if else block, it is executed this failed statement, then directly it comes to after if else blocks. That's what. So in this case, it won't check this piece of code and this piece of code. Directly it comes here and it will execute. That's what the if conditions are controlling your flow. So if I say 65, so directly again it comes here, passed in first grade, and after if else blocks, directly it is coming to your this else condition, and it is It is then after it is printing the after if else blocks, right? So whenever the condition comes true, whenever you are having multiple if else blocks, after that condition true matches, it won't execute any other statements as part of your if else ladder. Whenever it finds the expression true for the if condition, from that line onwards, it won't verify any other if else conditions. But in the other case, for suppose as it is 65, so it has to verify this obviously, then after it has to verify this, then automatically it comes here and it executes. But if you give here 15, so only this particular condition verifies and then it prints, and it won't verify this piece and this piece of code. That is how it gets executed. That's what I mean to say. uh, where the first if or I'll put in this way, till the first if condition true, it has to execute. Whenever it met the condition true, it will not execute any other if else conditions as part of your if else ladder. So it is going to improve little performance by avoiding the multiple condition checks. This is what multiple if else. This is what one if else, and again this is what another if else. We'll say this is if else ladder. We will say this is if else ladder, if else ladder, and we will see nested ifs tomorrow. I mean to say we can have if statement inside another if statement, or we can have if else statements inside a if block or inside else block, something like this. So this is what else I'm having here. Inside that else I'm having again if block, multiple if blocks. So these are nested blocks. Nested blocks are nothing but we can have if condition, again if condition. So here we can have, again if you want, again you can have one more if inside this. This is what nested if statements. So in the similar way you can make it if else also. Yeah. As my webinar is scheduled 7 to 8, it will wind up now, so we'll continue tomorrow at the same time. So I'm just stopping my recording. I will be sharing this video later. You can go through this. Thank you.